Welcome, everyone, to the Laws of Magic. My name is Dave DeLong. I'm a principal engineer at WeWork, and I'm excited to talk to you today about one of my absolute most favorite topics, which is fantasy novels. But before we get into that, I think we kind of need to answer the question of why are we talking about magic at a technology conference? There is a quote by Arthur C. Clarke that I love that I think really encapsulates the heart of the comparison between technology and magic. That is that any sufficiently advanced technology is indistinguishable from magic. We deal with a lot of really advanced technology. For example, iPhones, when you get right down to it, they're what you get when you combine some sand, some metal, and a bunch of weird minerals, and you mix them all together in the right way, and you end up with an iPhone. The way that our iPhones work themselves is magic. There's a tweet by Daisy Owl that I love that says, if you ever code something that feels like a hack but it works, just remember that a CPU is literally a rock that we tricked into thinking. But not to oversimplify, first you have to flatten the rock and put lightning inside it. The apps that we use every day themselves are magic. Through the apps on my phone, I can learn anything that I want. I can buy anything I want from anywhere on Earth and have it shipped to anywhere else on Earth, probably. I can communicate with other people via outer space, which is really cool. I can make strangers do things for me. Just, get somebody on TaskRabbit to do the craziest things. But I can also make a meaningful impact in my community. As we learned about from Kaya's talk this morning, the things that we do with technology can literally save lives. In addition, the frameworks that we write are magic to other developers. None of you want to learn how to display and mark up PDFs, and so we use the magic of other frameworks to do this for us. Dealing with cryptography is black magic, which again, none of us want to do. I hope you all never have to implement auto layout. And frankly, ARKit is just, it's bonkers, it's magic. Everything that we do is magic. So I want to talk to you about the 3 laws of magic. And these laws are how to build engaging magic systems. These 3 laws come from this man named Brandon Sanderson. He is my absolute most favorite author. And if you have not heard of him, take notes on this slide because this will change your life. As I said, he is a fantasy and science fiction author. If you're familiar with the series The Wheel of Time, he is the author who completed it after the original author passed away. In addition to finishing The Wheel of Time, he has his own books, such as the Mistborn series, the Stormlight Archive, and so on. If you add up everything that he's written, he has nearly 50 published works, and he's announced plans for another 40. So he has a whole lot of stuff that he's done. He's won lots of awards. He is incredible. He's just about the only author where he announces his book and I will just instantly pre-order it in about 4 different formats. Brandon has 3 laws that he follows when writing his books. And these are laws that he follows in order to make sure that the magic systems that his characters use and interact with are interesting and engaging and add to the overall story. So, the first law of magic says, an author's ability to solve conflict satisfactorily with magic is directly proportional to how well the reader understands said magic. There's a lot here. But when you get down to it, it is the idea that if you're going to use magic to solve a problem, you have to understand kind of what's going on in order to be happy with the solution. When we use magic via software to solve things in ways that are unsatisfactory, we get some pretty negative reactions. For one, it feels like a deus ex machina, where we're driving towards the climax of a plot, and then all of a sudden, the clouds part, and a god reaches out and snaps his fingers, and suddenly everything is all nice and hunky-dory. And there was nothing leading up to this that would suggest that this would be an appropriate outcome. With these sorts of solutions, we feel a lot of frustration. We feel like we've really wasted our time because it was completely unexpected. When it comes to software, we have this feeling, I could do this better myself. In fact, this is one that I have to struggle with quite a bit. Just before this talk, I was looking for an app for my watch to buzz me on the wrist when my time is up, and I couldn't really find one that did exactly what I wanted. And I'm just thinking, I could do this better myself. When we write apps like this, we get lots of support tickets because our users are confused. We get refund requests, which are not a sustainable way to build a business. We get 1-star reviews on the App Store. It's just not good. By comparison, satisfactory solutions lead themselves to some really positive reactions. One of my favorite is just the mind-blown reaction. And this is something that Brandon does extremely well in his books. He's got all of these little threads that he's bringing along, and then all of a sudden, everything comes together at a single point, and it blows your mind. It's one possible reaction. Another possible reaction is just kind of like the obvious reaction. Of course it should be this way. There is no other way in which it would make sense for this thing to behave. But I think the reaction that we should all be striving for is no reaction whatsoever, where the magic that we have built is so intrinsic to what we have done that it seems completely natural. There is an XKCD comic, which I love. I love pretty much every XKCD comic. But in this particular case, a man comes up and he asks, when a user takes a photo, the app should check whether they're in a national park, which is easy, given some location lookup, and check whether the photo is of a bird. And I'll need a research team in 5 years. To look at a photo and know that it's of a bird is complete magic. We all know how to do location requests. You figure out the boundary of a state park or national park. You look at the location on a photo, whether it's inside the boundary, that's easy. And yet, when we can add that magic of knowing whether a photo is of a bird, we can get this really amazing experience that feels completely natural, such as opening up the Photos app on your phone and searching for birds. To the average user, this seems completely natural. There's no reaction to the absolute massive amount of work that went into making this possible. Our goals for satisfying users are to minimize confusions and questions, to make the wrong choice impossible, but when they do make a wrong choice, to provide immediate and clear feedback. Let's take a quick look at minimizing confusion. Here's a struct that we might consider writing in a framework to represent a logged-in user. But there are a couple interesting problems with this that might not seem immediately apparent. For example, we have this method called login, which kind of, by its very nature, implies some sort of mutating behavior. Before we weren't logged in, after we are. And that mutation seems to be at odds with the fact that this is a struct, which are generally immutable values. We also have this notion of a user, but how do we get from credentials to user, and especially this non-optional user, and this other thing that's an authorization token that maybe is part of the credentials? Who knows? This is really confusing. But by reshaping this struct in just one small way, we can eliminate all of this confusion. So we'll start with that same struct. with those same properties of a user and an authorization token, but instead change that method to be a static function, where we log in given some credentials, and once it's completed, we either have a user session or an error. This is an API that cannot be misused. It cannot be misunderstood. There is no way exposed to create a user session, but how we can get one is immediately apparent. We can also make wrong choices impossible by not allowing them. When it comes to UI, we can disable and remove inappropriate elements. And when we're writing frameworks, we can restrict misuse through type safety. The type system in the compiler is incredibly powerful, and it allows us to do some really impressive things, which we'll see in a minute, when we provide it with immediate feedback. This immediate feedback principle is also really important because it's how we can teach our users how the magic works. In UIs, we use alerts and colors, tooltips, to suggest and provide hints along the way to the user of what they should be doing. In code, we have documentation and even compiler messages. And when we combine these together, we get some really cool stuff. For example, let's take a look at this hypothetical date and time API, which we all know is really complicated. This is pretty clear. I can start with the current month of August, add 1 month to it, and get September. But what would it mean to take September and add 3 seconds to it? September plus 3 seconds doesn't make a whole lot of sense. So it'd be nice to have a compiler error saying, hey, you can't do that, which we can do. First, we define the operator to adjust a month. So a month, this current month plus an offset of 1 month, great, that's fine. But we also define the impossible case, 1 month plus seconds. And here we'll have a returning never because there's nothing we could reasonably do here. But we can instantly mark it as unavailable. And this means that when a user attempts to use this, they'll be able to see it as possible through autocomplete because the function exists. But because it's marked as unavailable, they will get the compiler error saying they can't actually do this. And by so doing, we're using the type system to our advantage and teaching users along the way about the right way to do things. So this is the first law of magic. We want to minimize confusion. We want to teach how to use things, and we want to provide feedback. The second law of magic says simply that limitations are greater than powers. As developers, we have a lot of really amazing powers. These represent the things that we can do. Given enough guidance, we can create these really incredible apps. But what's really important are the things that we can't do. And in many ways, what we cannot do is more important than what we actually can do. And when we add limitations to our product, we can get some really interesting results. So let's start with some example powers that we can do, but add limitations to it. So we have the power to post things on the internet. We can take pictures. We can write stories. We can play solitaire. We can find a lost device. By themselves, these are all kind of mundane powers, kind of boring. Well, let's add some limitations, and now we start seeing interesting products fall out of this. So for example, instead of posting text on the internet, let's limit it to 280 characters, and we've suddenly invented Twitter. Instead of taking pictures, let's take pictures that get deleted after about a day. We've reinvented Snapchat. Or write a story that deletes itself if you stop typing for 5 seconds. This is literally a Mac app you can go download, and it's a way to force you to be productive. We can make solitaire, that's really okay, but instead let's make solitaire, but in undo is an in-app purchase. And now suddenly, as a user, I'm being a whole lot more careful about how I play solitaire. Finding a lost device, kind of interesting, but let's also do it without compromising your user security. We do this, and we've reinvented the new Find My feature. These are really cool things, and by adding some limitations, we've turned our powers into something far more interesting. Limitations force us to make choices. We say that necessity is the mother of invention, that when we are confronted with limitations, then we become creative. We also have this concept of choice paralysis, where if we have too many choices, we are unable to make a decision. How many of you go to a restaurant and you're confronted with this 4-page menu of possible things you can order and you just have no idea what to do, so you default to a hamburger, right? I do this all the time. On the other hand, if you have a limited number of choices, then the decision is easy. Do I want chicken, beef, or pork? Simple. And so we recognize this important principle that freedom from choice can be just as empowering and valid as freedom of choice. So, the second law of magic says that when we are stuck, we can add limitations to kind of jumpstart our creativity. That our unique constraints that we are under produce really unique results. And often the final product that we produce is more reflective of the limitations that we were operating under than our actual abilities. The third law of magic says, expand what you already have before you add something new. And in order to talk about this, I want to talk about a concept called the long tail. The long tail is the idea that if you have this exponential graph, or like this, we spend a lot of our time focusing on the features that everybody's going to use, right? The things that are, 90%, 80% use cases. And we kind of ignore the things that 10% of our users will use, or 5, or 3, or 2. And so all that other stuff gets left out. But the really interesting thing about the long tail is that when you consider all of the stuff we left out, that is actually 50% of the area. By neglecting the long tail, we lose out on half the potential usage of our product. The long tail is why apps feel native. When we build those features out in the long tail, we're building out features that not many people will use that single feature, but that everybody will use in aggregate. And these are things like localization and accessibility. But they go on for so much more than this, and even include things like AppleScript support in a Mac app. You add up all of these different things, and you are hitting 50% of the potential usage. One example of an app that really meets the long tail is an app I love called Deliveries. And by itself, Deliveries is a pretty simple app, right? You put in a package tracking number and it tells you where in the world your package is. But it fills out this long tail. It has rich notifications, extensions, a Mac app, and one of my absolute most favorite things is if I copy some text out of an email that includes a package tracking number and I go to Deliveries, it auto-scans my pasteboard, finds the tracking number, and suggests, hey, it looks like you've got a FedEx number here. Can I add this for you? For me as a user of this app, that sort of magic of these little small features really makes the whole experience worthwhile. The way that Brandon talks about this in his books is summed up by what one character says: there's always another secret. The third law of magic says that when we build these secrets into our app, that when we expand what we have before we add something new, we add this hidden depth to our products. And discovering that hidden depth is an exciting thing for our users. It's what makes them go up to another person and say, like, hey, I was using this app and guess what I found? It does this crazy weird thing, but it's totally perfect for my use case. It's that deep system integration that makes it fit in seamlessly with everything else. So, these are the 3 laws of magic. That being satisfied with a solution that uses magic requires understanding to some degree how that magic works. That the limitations that we operate under are more important than the actual abilities. And that when we are faced with the idea of, well, should I just go work on something else, or should I add to this, that we should remember to add, and add that hidden depth to our products. Now, this is an array of laws. And like all good arrays, it actually starts at 0. And the 0th law of magic says that when none of the other laws help you know what to do, err on the side of awesome. Thank you very much.